Hello and welcome to another lesson in PIC microcontroller construction and programming. Today we will be looking at the Paralax PING ultrasonic distance sensor. What this sensor does is it sends ultrasonic waves out to basically bounce off of any type of object, and it basically will measure the distance between the object and the sensor. This is very useful in robotics and any type of measurement systems. And what's nice about this is that it's a fairly inexpensive device. They're about 35 bucks, I think, 25 to 35 bucks, somewhere around in there. You can obtain these locally, usually at your local Radioshack, or if you don't have access to a Radioshack, you can always go on Paralax's website or Radioshack's website and buy them from there, purchase them that way. This is basically a really good illustration of what it does. We'll have our microcontroller circuit. Basically, with a start pulse, it sends a chirp out, hits an object. Once it's reflected back, it detects it, and it sends basically an echo pulse time back. So fairly simple to understand. You've got 3 pins. You've got a ground, 5 volts, and a signal pin. Now the signal pin is kind of interesting. It works both as the input and output pin, so just as it says IO pin. It sets looking for an input pulse. The minute you generate a pulse for it, it will then switch to output mode, and it will output the echo response from it. And I'll show you how to detect all that and generate it in code next. So let's go ahead down and look at the communication protocol. Basically how it works is you've got, here's your impulse, so you're going to give it an impulse. Then it will then send out a chirp. The minute you finish that impulse, it will send out a chirp, which is about a 40 kilohertz ultrasonic burst. I think it's, yeah, there it is, set up here. And then once it's done with the burst, it will then wait. This will go high, and it will wait for that burst to come back. And once it gets reflected back, it will then go low. And basically, the time in between the rising edge and the falling edge of this pulse is the distance. So you can correlate that to the distance. So that's basically how it works. Very simple to understand. Now the data sheet gives you a lot more information, like gives you kind of some do's and don'ts. Ideally the object is straight ahead and it's a fairly large object. No little tiny things, otherwise sometimes it can get flunky. If you hold it at an angle, make sure it's at an angle to where the reflection won't, be like this, be bounced away from the sensor. Things like that, just kind of more common sense stuff. One thing I will caution you guys with breadboards about is that make sure to put it on the very edge of your breadboard, so that way basically these little sensor discs stick over the edge, like the edge of the board may come to like here and not way out here, because remember, when this wave comes out of here, it's not in the XY plane only, it comes out in the XY and Z plane, so it goes this way and this way, as well as basically into the screen and out of the screen as well, from top to bottom, left to right, and forward and backward. So anything that is too close to the sensor below it or even above it can sometimes cause, if it overlaps far enough, can cause a reflection to happen and basically give you inaccurate data. It will say that you're closer to an object than you actually are, because it's actually the bottom or the top casing or whatever it may be. Like I say, a lot of the breadboards that are mounted to a board, sometimes that board will overlap the edge of the breadboard a ways and cause reflection problems. So make sure and watch that. Remember that it moves in the Z-axis as well as the X and Y. They give you some test data and just kind of a whole bunch of information. They even give you a sample way of hooking up, and as you can see they keep it where it hangs off the edge of the breadboard. They don't put it like way back over here to where the breadboard might be underneath it. They keep it away from it. So make sure and keep that. They even give you some sample code in the BS2 programming language, but we'll do it in the CCSC programming language, so that way you can see it, since that's what our tutorials are about. Okay, well, let's go ahead and take a look at the hardware. It's very simple to understand. What we've got our 7805 voltage regulator. We've got our mem clear tied to it high, and we've got a switch. How we're going to do, what this is going to accomplish is we're going to have it where if you place an object in front of the sensor, you can press the switch. It will then store that distance measure in memory, and then when you move the object either basically they'll set up a threshold, and if you have the object in the same spot or closer to the sensor, it will light this LED. If you have it far away from that threshold, it will extinguish the LED. So therefore we have our LED, 470 ohm current shunt or current limiting resistor. We've also got, here's our pins for our parallax sensor. We've got the VCC of the sensor tied to 5 volt, VSS tied to ground, so power and ground. We've got the signal pin coming into RB1. So that's basically the gist of the hardware. That's basically how it's going to work. We will go ahead and I'll show you how to do the code in the next video. So I'm going to go ahead and stop here, and we'll pick back up in part 2.